All right, so for your kinematics unit exam, okay, there are going to be a few topics here, okay, that I'm just going to kind of quickly review and tell you, these ones are on there. These things are on the test, and then I'll tell you a little bit more about the structure of the test after we go over the topics that'll be on it. Okay, so the first thing that we went over was basically a review of Science 10, scalar versus vector quantities. Okay, it's not that there's necessarily going to be any outright like questions about, oh, is this a vector quantity or this a scalar quantity? I mean, that could be like one multiple choice question that does something like that. But you need to know the difference between scalar and vector quantities, because if you don't, it'll be nearly impossible to do any of the problem solving correctly. Okay? If you're reading a question that's talking about, this velocity and that velocity and this displacement, and then at the end you don't put a vector on your answer, that means you didn't understand scalars and vectors. Doesn't mean you didn't understand how to use v equals d over t or something like that. It's that you forgot velocity is a vector quantity. Okay, so that's really where that's going to come into play, is understanding this one's vector, this one's scalar, okay, and how we treat them if they're vector versus scalar. So, okay, that's the stuff you need to kind of review on that. Okay, so the ones we went over, okay, we've got that our scalar quantities were time, distance, speed. We didn't deal with energy or work in this unit, but they're also scalar. Okay, vector quantities would be displacement, velocity, and acceleration. Okay, those are our vector quantities from this unit. Okay, so I'll kind of give you a better example here of what I'm talking about. My Science 10 physics unit exam, last semester, I had 48 kids, and here's how the question went. I gave them the acceleration of an object, I gave them the initial velocity of the object, and I gave them the time, and I asked them to calculate the final velocity of the object. 45 of 48 students did not put a vector on their answer, which was really what that question was testing. Do you remember that velocity is a vector quantity? Apparently 45 of 48 of them did not know that. And I take personal responsibility for that, as I was the one who was supposed to tell them that. Okay? Actually, I did tell them that over and over again. But I don't know what happened. Only 3 people remembered to put down on their answer. Okay? So there's an example of, do I need to remember which things are scalar and which things are vector? Yes, because that'll cost you a mark on a problem-solving question like an acceleration problem. Okay? So make sure you know which ones are scalar and which ones are vector. Okay, that same day we reviewed the use of v equals d over t. Okay, that could be speed equals distance over time, formula on the left, or it could be velocity equals displacement over time, formula on the right. Okay, and we also learned that this could be written this way as well. Final position minus initial position over time, because displacement really is just your change in position. All right, are there going to be any 5-mark problems to do with v equals d over t? No. There might be a 1-mark multiple choice question involving doing a simple calculation of v equals d over t, but no, I'm not going to burn a 5-mark written response item, okay, on a v equals d over t calculation. That said, it is part of projectile motion. You do have to use v equals d over t in projectile motion problems, so you do need to know how to use it. All right, questions on the first topic there? Okay, second topic, graphing. Okay, we went over 2 different kinds of graphs, the same 2 that you learned about in Science 10. Position versus time graphs and velocity versus time graphs. Okay, when we were going over your acceleration labs yesterday, okay, I told you that on your test you can expect to see both in the written response section of the test. Okay, so that means that there'll be some active problem solving to do with both types of graphs. So being able to read and interpret and calculate the things that you have been taught to do with each graph will be important. Okay, so from a position versus time graph, okay, or a velocity versus time graph, some things you might be asked to do, okay, would be to do y equals mx plus b calculations. right? You were asked to do that with your position versus time graph, like, you know, how far would the object go in 20 seconds, okay? Or how long would it take to reach a position of this much, and you had to manipulate y equals mx plus b for y or for x, okay? Nothing difficult, but okay, being able to do that is something that you'll be asked to do. And similarly with a velocity versus time graph, okay? So that's one possibility. You get a graph that's a linear fit, and you have to use y equals mx plus b. Now, I'm going to say this a different way, but it's kind of repeating myself. If you get one of these graphs, and it has the equation on it, that is, I give you the equation for the line on the graph, should you do as many calculations as possible using that line, or using that equation? Yes. Okay, if I'm going to go to the bother of giving you the equation for the line, it means I want you to use it. Right? And we talked about how yesterday that's going to take into account all of your points rather than just the first and the last one, and so it's more accurate to do it that way. Okay, the other way that you could be tested on graphing, okay, because we talked about this with both position and velocity versus time graphs, is when you don't have a linear fit. Okay, so let's say I've got a position versus time graph here, okay, and the object goes like that. Okay, I might ask you, what's the total distance traveled? Okay, would you be able to calculate that from the graph? Right? How far does it go here? I know there's no numbers on the graph, but you can still tell me how far it goes during this part. 0, right, the line's flat, position's not changing, so it didn't go anywhere during that part, okay? And then you can figure out, okay, it went this far, and then it didn't go anywhere, and then it went back this far. Okay, that's calculating the distance, okay? I could also ask you to calculate the total displacement over the whole trip, which would be final position minus initial position. I might ask you for the average speed or the average velocity over the whole trip. But a graph like that, you won't get an equation on it because it's not a linear graph, okay? And so then you would have to do it differently. And the same could be true for a velocity versus time graph, okay? You could get a velocity versus time graph that maybe looks like this, okay? And it asks you to calculate the total displacement. Well, then you got to find all those areas, okay? Or you need to find the acceleration between this time, and then you would go A equals VF minus VI over T. These were all things that you were asked to do in class, okay, to do with a graph, so expect that you're going to be asked to do them or demonstrate your ability to do them again. Okay. Questions on the graphing stuff? Okay. So there's some graphing questions on the unit exam review package. But they're not as good as the ones that are in the work booklet further back to do with graphing. You're better off to probably go over those ones again, okay, if you're looking for some practice ones. Okay, and then acceleration. Right? There'll be, I want to say, 2 problems on acceleration in the written response, and a couple of questions in the multiple choice as well about acceleration. Okay, what it is, okay, what happens during acceleration, that kind of stuff. Okay, but we have a lot of different acceleration formulas, okay, so you need to make sure you write down your givens and pick the right formula and all that stuff. Okay, and then vector addition. There will be a vector component addition problem in the written response. Okay, so this vector plus that vector. Okay, one of the vectors is straight along a compass direction and the other is angled, just like I told you it would be, okay, when we were in that section of the unit. So make sure you know how to draw them tail to head and get your x's and y's and calculate your result. Okay, because you'll have a question like that. And as I said to you the other day, you'll have a boat question. Okay, remember there's 2 kinds of boat questions. Rowing across, in which you end up downstream, and going across, in which you end up straight across because you row slightly into the current and allow it to push you back.
For the ones that go actually like straight across,
Mm-hmm.
they usually say that like the person wants to go straight across,
Yes,
and then
those-
ask you to solve for what they would have to do.
Yep,
Like, it's always obvious what they want to.
it'll be very obvious which type it is, yeah. All right, so just make sure you know, okay, how to do your vector addition stuff, like you said, that we talked about in class, okay? You know, if you have, let's say, you know, one vector like this, and then you have another vector like this, okay, your resultant goes like that, and you gotta calculate your x's and y's, okay? You guys were good at that, so just make sure you practice it so it's polished, okay, for the test. All right, questions on the vector addition stuff? And you got one of each type of projectile motion problem. One horizontally projected projectile, one angled projectile on your unit exam as well. Okay, so there are 7 written response items or problems for a total of 48 marks. Okay, because some of the graphing questions have like an A and a B and a C. Okay, so they've got, you know, I want you to calculate a bunch of different things from the graph. Okay. So, as I said, you got a horizontally projected projectile, you have an angled projectile, your boat question, acceleration problem, graphing question, vector addition problem, and graphing question. There's your 7. Okay. Does that help you focus your studying? Now you know exactly what I'm going to ask. Okay. In the multiple choice, there are 17 multiple choice questions. Okay, and they're basically checking things like terminology, you know, different, you know, scalar versus vector, really simple calculations like situational stuff, like, you know, if you went to Home Depot and then back home again, what would your total displacement be? Like, stuff like that. Okay. So then, yeah, some simple calculation stuff to do with vectors and scalars. There's a couple of graphs as well, but they're mostly interpretation or very simple calculation kind of questions in the multiple choice. Okay, but there's like 3 or 4 graphing questions in the multiple choice. But again, they're interpretation or simple calculation. They're not y equals mx plus b and do all this extravagant stuff. Okay. And then there's a couple of questions about projectile motion, just your understanding of it, the principles of it. They're not calculation questions, they're just understanding how projectiles work. Okay. That's it, that's what's on your test. Okay. So 7 written and 17 multiple choice. The whole test is out of 65. So you will have a full 85-minute class to write it. Okay, that is, I will let you write into lunch hour, let's say about 10 minutes. So you'll get 95 minutes to write it, which should be more than enough because it only took me 18 minutes to make the key. Okay. So if you can multiply how long it took me to do it by 4 and still have it fit in the writing period, the test is like really in your favor. Okay? If we can only multiply it by 3, then it's a little harder. You have 95 minutes and it took me 18 minutes. You do the Okay. Questions from you guys? Anything you want me to cover in a little bit more detail, or review again, or demonstrate?
Could you use some graphic notions?
Graphing? Okay. Like, how about this one? It's like I read your mind. Yes, scary. I didn't read your mind. Okay, so here's just a position versus time graph. So this would be one where if I gave you this graph and that equation and asked you to do some calculating, I would want you to use the equation for the calculating. So a question like this, maybe something I would ask would be, what would the position of the object be after 50 seconds, 50 seconds? Right? Now that's not on the graph. I can't look that point up. But I can calculate it because I have the equation. I asked, what's the position at time 50 seconds? So I know the slope, which is the velocity. Okay? I know the initial position, which is the y-intercept. Okay? And I was told 50 seconds. Is that a y or an x value? That's an x value. So can I solve for the position, which is a y value? All I have to do is plug what in? 50 for x for the x value, and I'm solving for that. So you could have something like that. Or the reverse. What would the position of the object be at time 19 seconds? We don't have a point on the graph at 19 seconds, and you would have to solve for x. Okay, sorry. I said that backwards. How long would it take for the object to reach a position of 32 meters? Okay. And then so you solve for x, okay, in that situation. Does that sort of make sense? That would be one type of graphing question. Okay. If it was a velocity versus time graph, okay, then maybe I would ask you to calculate the acceleration. Okay. Well, that would be really easy. How many marks would that be out of? 1. Why? Because it's right there. Okay. You don't have to calculate it. I might do that. Okay. That just tells me, do you remember what the slope of this graph represents? Okay, so if I give you a graph like this, it's got the equation on it, okay, it's a velocity versus time graph, and I ask you, what's the acceleration of the object? That would be a 1 mark question, and it'll say 1 mark in brackets at the end of the question. If something's out of 1 mark, how much calculating is there? None. Okay, the answer's right in front of you. That's a big hint, by the way. Okay, if you're ever on a test and the question is out of 1 mark, there's nothing to calculate. You'd be amazed how often I have people do 6 marks worth of work for a 1 mark question. And then they get it wrong because it didn't require any of that work.
So the acceleration is just before the x there.
Yeah, it's the slope, right? And we did this back in when we talked about these, but if we solve for the slope, we have m equals y minus b over x. On this graph, y is my final velocity, right? Be up here. B is my velocity at time 0. So it would be my initial velocity, and x is time. That's where that formula comes from, right? So it's just a matter of either you have to figure that out again or you just remember it from when we did it. Okay? And it's the same on a position versus time graph. Okay? If I manipulate this one, so I've got m equals y minus b over x, y is my final position. B is my initial position. That calculates displacement. X is time. That calculates velocity, right? Okay, so things like that. And then the other way, okay, like we said, you could have a graph that looks like this, right? And maybe I ask you to calculate, since this is a velocity versus time graph, what's the acceleration between, I don't know, 0 and 12 seconds. Okay, so I'd go, okay, well, my final velocity is 0, my initial velocity is 4, okay, divided by 10, right, negative 0.4 meters per second, okay, squared, okay, something like that. Okay. Or maybe I ask you to calculate the total displacement. I wouldn't give you a graph that looked like this if I was asking you to do that, because there's way too many shapes here, okay, it would take you way too long, right, but you could look at, you know, something like, all right, so I got, you know, these triangles or whatever, find all the shapes and calculate. You could have something like that. Okay. Similarly, you could have a position versus time graph with an irregular shape, and then you're going to be asked to do something like, what's the total distance traveled? Okay, so I'd go, okay, starting here at, I don't know, it's about 6 meters. Obviously the graph would be readable, you'd know all the numbers. Okay, so I go from 6 to 18, and then I add this part, and then I add this part, and then I add that part. Okay, just like we did in class. That's all I'm gonna ask. Okay, what else?
So like, can you try and give us an example of an interpretation question? I mean, I guess it's sort of this interpretation.
Okay, so on an interpretation question, this is in the multiple choice section, and I say, what is the object doing between 5 and 10 seconds? That would be an interpretation question. This object is traveling backwards at a constant velocity. Okay, that would be an interpretation question. Yeah, that's a good question. I didn't really clarify that. So, okay. Other questions? Fair?
Can you do a boat question?
A boat question? Sure. Okay. Never anything new. No surprises ever. Okay. All right, so a person is rowing directly north across a river at 20 meters per second. Okay, is this a rowing across or a going across? Rowing across. Okay. The current is due east at 0.75 meters per second. What's the resultant velocity of the boat relative to the shore? Okay, so here's what I've got. I've got 2.0 meters per second. Okay, I've got 0.75 meters per second. This would be my resultant, okay, velocity there. Okay. Now they don't want this angle, they want this one. So that's fine, I'll just go 90 minus whatever that comes out to. Okay. So I just have to calculate the hypotenuse. All right, so that'll be square root of 2 squared plus 0.75 squared. All right, so we're looking at 2.1 meters per second. Okay, and then I'd have to find that angle, so I would just go tan to the minus 1 of 0.75. Actually, I'd go the other way. 2 divided by 0.75 will give me the other triangle.
0.2.
I have 0.2. All right, so it would be 69 degrees from the shore. Yeah? All right. Then the other part of this, how far downstream will they be when they get to the other side, okay, if the river is 50 meters wide? All right, so now they're telling me some other information. Now I know that the river is 50 meters wide, and I'm crossing it at 2 meters per second. So how long does it take me to get across the river? 25 seconds. Okay, T equals D over V, right? 50 over 2, okay? It's 25 seconds to get across. Okay, all 25 seconds, I'm moving downstream at 75 meters per second, okay? Or sorry, not 75, 0.75 meters per second. That would be a really fast river. Okay, so we'd have 0.75 times 25, right? So we're looking at 18.7, or actually we'd have just 19 meters. We only have two significant figures there. Okay, 19 meters downstream. Yeah. Okay, what else? Okay, well, there's no other, oh, sorry.
Can you do like the projectile motion where you have to find out like how fast it's going from like the vertical displacement?
From the vertical displacement. Oh, from the maximum height, find out its
Yeah.
projected velocity? How about I give you a spoiler? I'm not going to ask that. Okay? I'm going to ask you, okay, on the exam, okay, you're getting the plain Jane one we've done like 20 of. Okay? Horizontal distance, maximum height. Okay? That's what I'm going to ask. I'm not going to try and trick you with a weird worded question. Okay? I can still go over that if you want. but I'm not gonna give you one like that. Okay, the trick to doing that one would be, okay, if I give you the maximum height, okay, this here, and I ask you to find the projected velocity, okay, I just have to remember that here, VF is 0, A is negative 9.81 meters per second squared, and I solve for VI. Okay, once I have VI, then I would have this side of the triangle. They probably have to also tell me how far it went so I could get V horizontal, or I'd have to know what the angle was, one or the other, okay, so that I could get the hypotenuse. Right? As long as I had two sides or a side and an angle, I'd be able to get that. Yeah. Okay, what else?
Acceleration.
Acceleration problem? Okay. Nobody asked for one of those. I always keep everything everybody asks, just in case it comes up again. Okay, I'll make one up. Okay, so there would be an acceleration problem. Okay, so this problem here gives us a few things. Gives us VI. Okay, 12 meters per second up. Okay, it doesn't outright tell us this, but we know it because we're throwing something. So the acceleration is 9.81 meters per second squared. And incidentally, this is not during the throwing process. This is once it leaves the hand. Okay, because when it's in the hand, its acceleration is not 9.81 meters per second squared down. It's whatever the hand is accelerating it at. Okay. They also tell us VF is negative 9 meters per second. Right. So we're looking for the displacement, okay, of the object at that point. Okay. So what formula would I use there?
VF squared equals V items.
Yeah, exactly. Okay, this is why we want to write down our givens. It helps us to pick our formula. This is the only formula I have that will solve this in one step. Is there a way to do this in more than one step? Yes. Why would you do it in more than one step if you can do it in one step? Okay. So looking for D, so I'm going to subtract VI over to the other side. So I'll have VF squared minus VI squared, and then I'll divide both sides by 2A, and that'll leave me with D. Okay, and when we plug in our numbers, that's going to be negative 9 squared minus 12 squared divided by negative 9.81 times 2. So, negative 9 squared, not that it matters, so when you square in a negative number, it becomes positive, minus 12 squared divided by negative 19.62, because that's 2 times 9.81. All right, so its displacement will be 11, actually we only have one significant figure there because I was a doofus when I made up the question. Okay, so it would be 1 times 10 to the 1 meters up. Okay, I would not do that to you on a test, by the way. You'll never get a 1 significant digit number. All right, is that good? What else, guys? Okay, well, if there aren't any questions right now, good.
Do you have the like projectile motions rolling
Off an incline? Okay, not gonna be on the test, but I can do it. Okay, because I said it's just gonna be projected horizontally for the, right. Okay, but if we had one like that, it would look something like this. Okay, so the ball's gonna roll off of here. Okay. So if this incline is 30, this angle here is also 30 degrees, right? Law of similar triangles. Okay, so if I've got that, let's say the ball rolls off here at, I don't know, 18 meters per second. Okay, so that means that at time 0, it's moving downwards and horizontally. Okay, so same as any other projectile motion problem, I still want to break this up into its horizontal and vertical parts. Okay, so from a vertical perspective, the acceleration is negative 9.81 meters per second squared. VI is the opposite side in that triangle, so sine of 30 times 18 is negative 9 meters per second. I have to recognize that it's down. I don't really need to make it down, but I made this one negative, so I made that one negative too. Yeah, they can all be positive when I calculate. All right, something that's different on this one than from the launched positively. VF and VI are now not equal. Okay, they're not landing at the same height, so that's no longer true. That's fine. We don't really need it to be true. We can still figure this out. Okay. So from here, I think I would have had to give you probably one more piece of information. I would either have to tell you how far from the base it lands, so you'd have the horizontal distance, or I would have to tell you how tall the building is. So let's say that on this question, I told you that it lands 16 meters from the base of the building, okay? And I want you to find the height of the building. Okay, so basically I'm looking for the vertical displacement. Okay, so if I'm looking for vertical displacement, I need one more piece of information. I either need VF or I need T, one or the other. Okay, I would say I don't really have any way to get VF right now. Okay, but I can calculate time using the horizontal information. So I'm going to go back over here and write down everything I know horizontally. I know horizontally it's going to travel 16 meters, and I can calculate V horizontal. Okay, so that'll be the cos of 30 times 18. So 15.6. Okay, so we have 15.6 meters per second, okay, as our horizontal velocity. Now we know what our what our horizontal distance is. So now we calculate our time. It's going to be pretty small, close to a second. Okay, so we got d over v, 16 divided by our answer there. Okay, so 1.02 seconds. That I can bring back over to my vertical information. Okay, and now I can calculate d using this. Okay, I could also calculate VF and then calculate D if I wanted to do it in 2 steps, but again, why? When we can do it in 1. Okay, not that you get it wrong, you get it right, it would just take you longer. Okay, so we've got 9 times 1.02 plus 1/2 times 9.81 times 1.02 squared. Okay, and I just made everything positive because it's all down anyway. Okay, so 9 times our answer plus 0.5 times 9.81 times our answer squared. All right, so it's 14 meters high. Okay, any other ones? Okay. We still got a bit of time here, so if you want to start maybe having a look over the review package that's at the end of the digital workbook for this unit, maybe trying some of the questions. I did post the key yesterday. Okay, so the key should be in Google Classroom, because I didn't post a podcast yesterday. So I just posted the key to the review package. Right, so you can check your answers as you go. And if more questions come up while you're working on that, I'm happy to go over them.